Hi guys, welcome to the fifth part in this video series on writing a bare minimum chess program in C. And in this part we're gonna take a look at most boring part of the entire chess program we have written already, and this is the user interaction. So it's really like the most ugly part of this program. For I don't really like to implement things like this, but nevertheless it's needed in order to make the program be able to play with the user. So the bare minimum implementation of this interaction is actually implemented over here, so there won't be any move legality checking. So in this version you would be able to kind of cheat, so any of your pieces would be able to go basically anywhere. Well, maybe it's not really good, but still it's the easiest way to do things. And I'm sorry for this code. This part of the code is really ugly, but I'm just a bit tired. I've been recording this video series the last 2 days, and I'm really tired now. And tomorrow I'll be busy, so I don't know where again I would be able to make some videos, at least at this point. So without further ado, I'd like to just explain the last part. So we have ended where we have ended with the implementation of the loop where computer plays against itself, and it's where commenting this debug constant becomes handy. So now this part of code, this is not executed, and we jump right into this part. And another little variable to add is the user move. This is the array of characters to store the move entered by the user in a format like E2, E4 or something like that. And now the loop itself, basically, so where the user could have played against the computer. So the first thing to do, we have to just clear the user input from the previous iteration. So every time this array of characters user move would be initialized to zeros, and then we have to get the user input, so store what you've typed in your keyboard to that particular array, and then in case if you didn't really type anything but just hit the enter, the loop would continue until you will actually input some move. And then we define another couple of variables. These are the user source and the user destination squares, and these are needed to store the converted, the parsed user move. The user move would be parsed into from square and to square, and this particular move would be actually made on board without any legality checking for now, as was mentioned. And then we loop through all of the squares, and that's needed for the parsing reasons. And again we ask if the square is on board or not, and if it is, then we would reference the notation array that was shown over here. Reference the notation array. The way we do it, we use the string compare function, which compares the first two characters of the user input with the reference in this notation array, and in case of match of the user inputted address of the board coordinate and the value in that array in the notation array, well, in that case the square we are now at, which is stored at this square variable, is assigned to the user source square or the user destination square, respectively. So first we part the first part, that first two characters of the particular user input, and then the other two characters. So no checks for the legality of the input, so the user has to input correct moves, otherwise the undefined behavior will occur. Okay, and then we make the user move just exactly the same as we did in the move generator. So we put the reference of the board user square, so actually the piece that stands on the from square entered by the user, we put this to the user's destination square, and then we clear the user from square. And now an interesting part, that the pawn promotions were done in the move generator in a quite a pretty manner using the step vector variable, but in this case the step vector variable is not really available, so we will do this in a dumb and ugly and code monkey way. So we just ask if the destination square, if the piece at the destination square is 9 or the white pawn, and if the destination square is greater or equals than 0 and less than equals than 7, or the basically this is the 8th rank, then or if the pawn is 18 on the black pawn and the rank is the 1st rank, then convert this pawn, the type of the particular given piece, to queen. Each time this would be either white queen or black, so we only convert the type here, and then we print the board. Then we change the sign in exactly the same manner as we did in the recursive search call. And now it's time to force computer to make a move, and here we call the search position function with the values with the arguments of the site. The depth is defined over here, so the more depth here, the stronger computer plays, but the longer time it takes for him to make a move. For I did forget to say that the alpha beta pruning becomes really efficient only when the move ordering is involved, and the move ordering techniques is the separate topic which could be discussed, but the bare minimum chess program doesn't really need that. So the alpha beta search could still work, but it's really quite inefficient. So this program is generally very weak, very slow, hence very weak. And the last two arguments is minus 10,000 and plus 10,000s are actually minus and plus infinity for the alpha and beta respectively. And now, as far as the move has been searched, the best move has been saved in the variables of best destination square and the best source square, and the computer move is made on board. And again, if the computer move is a pawn promotion, then in this case the pawn is converted to the queen, and then the side is changed again, and then print the board, and finally print the score. And here is the checkmate detection. So in cases if the score is equal to infinity or minus infinity, then we are actually in the checkmate state and the game is over. So we break out of this main game loop, and finally we print the best move found by the computer so far. Well, and now just let me quickly demonstrate how this program is going on. So I play e2, e4, and he plays d4, d75. I don't really remember the name for this opening. That's a bit of a shame, for I've been doing chess for quite a few years. Okay, e4, e4 takes on d5, queen takes. Okay, and now let's just make the things short. I just want to demonstrate how the computer can see the mate in 1 basically, and I play just king e1 to e2, and I get checkmated here. So just in order to show you that the computer can see the mate. Well guys, this is it for this series. I was very excited about making this. I wanted to make this series quite a long time ago, and finally I did it, and I did this for you. I really hope that it will help most of you jump right directly into chess programming, and this is an amazing world where everybody could express himself in a different manner, and it's really cool. And the next video would be the last part in this series. This would be a kind of bonus series where I would play a real chess game against the program I've written, so we will see how strong it is, or maybe how weak am I, or how weak I am. Okay guys, see you next video, bye.